Learning objectives. In this chapter, the user would be learning about the .NET framework and the following in detail. Common language runtime, common type system, common language specification, the base class library, the .NET class library, intermediate language, just-in-time compilation, garbage collection, application installation and assemblies, web services, unified classes. .NET is a wonderful platform for developing modern applications. It provides a rich set of functionality out of the box. This means that as a developer, you need not go into low-level details of many operations such as file I/O, network communication, and so on. ASP.NET provides an event-driven programming model with complex user interface. .NET provides a fully object-oriented environment. .NET provides multi-language programming for applications. .NET provides promising platform for programming such devices. Memory leaks were a major reason in failure of applications. .NET takes this worry away from developer by handling memory on its own. .NET is the only platform that is built with XML right into the core framework. .NET does not require any registration as such. Much of the deployment is simplified. .NET platform is safe and secure for enterprise applications. CLR works like a virtual machine in executing all languages. All .NET languages must obey the rules and standards imposed by CLR. Examples: object declaration, creation and use, data types, language libraries, error and exception handling, interactive development environment, IDE. Common language runtime is considered as the heart of the .NET framework. .NET applications are compiled to a common language known as Microsoft Intermediate Language, or IL. The CLR then handles the compiling of IL to machine language, at which point the program is executed. It works like a virtual machine for executing and to execute the code written in different programming languages, and it must obey the rules imposed by CLR as shown. Common language runtime is a mixture of different programming languages. With the help of common language specification and common type system, a standard class framework is also developed for automatic memory management. Common language runtime handles the errors and executes the code in a safe way. It allows for deployment in multi-platform by removal of registration dependencies, and it increases the safety by versioning the application. Common type system. This binary compatibility between language types is called the Common Type System, CTS. To support multiple programming languages, ability to reuse the FCL framework class library, each programming language must be compatible. The built-in types are represented as types in the FCL. It also has a built-in types for different data types like C# int data type, which is the same as a VB.NET integer type, and their .NET type is a system. int32. This is a 32-bit integer named int32 in the system namespace of the FCL framework class libraries. Common language specifications. CLS is a set of rules that specifies features that all languages should support. Goal: have the .NET framework support multiple languages. CLS is an agreement among language designers and class library designers about the features and usage conventions that can be relied upon. Example: public names should rely on case for uniqueness since some languages are not case-sensitive. However, one of the benefits of having a CLR with CTS that understands intermediate language and a framework class library that supports all languages is the ability to write code in one language that is consumable by other languages. The base class library. The .NET framework provides a set of base class libraries which provide functions and features which can be used with any programming language which implements .NET, such as Visual Basic, C#, Visual C++, etc. It contains standard programming features such as collections, XML, data type, definitions, etc. The .NET Framework base class libraries contains I/O for reading and writing to files, reflection and globalization to name a few, all of which are contained in the system namespace. As well, It contains some non-standard features such as LINQ, Addo.NET for database interactions, drawing capabilities, forms, and web support. The base class library namespace. Here we are seeing a few base class libraries like System. This class library contains the fundamentals for programming such as the data types, console, match, and arrays, etc. In another class library, System.CodeDOM supports the creation of code at runtime and the ability to run it, and also a class library like System.Collections contains lists, stacks, hash tables, and dictionaries. Few base class library namespace. System, System.CodeDOM, System.Collections, System.Configuration. .NET Class Library. .NET Class Libraries are a standard library for .NET Framework implementation of the standard libraries as defined in the Common Language Infrastructure. The FCL is a collection of reusable classes, interfaces, and value types. The BCL is the core of the FCL and provides the most fundamental functionality, which includes classes for input, output, string manipulation, security management, network communications, thread management, and other functions. The class library framework above, the base classes data and XML classes are hosted. Data classes support persistent data management and include SQL classes for manipulating persistent data stores through a standard SQL interface. XML classes enable XML data manipulation and XML searching and translations. The .NET class libraries have another layer of web forms, including classes that enable you to rapidly develop web GUI applications. Windows forms support a set of classes that allow you to develop Windows GUI applications, facilitate drag-and-drop GUI development, and provide a common, consistent development interface across all languages supported by the .NET framework. Intermediate language. Intermediate language IL is an object-oriented programming language designed to be used by compilers for the .NET framework before static or dynamic compilation to machine code. The IL is used by the .NET framework to generate machine-independent code as the output of compilation of the source code written in any .NET programming language. IL is a stack-based assembly language that gets converted to bytecode during execution of a virtual machine. It is defined by the Common Language Infrastructure (CLI) specification. As IL is used for automatic generation of compiled code, there is no need to learn its syntax. This term is also known as Microsoft Intermediate Language (MSIL) or Common Intermediate Language (CIL). Intermediate language can be executed on any computer architecture, allow compiled source code, support the CLI specification. Intermediate language provides better performance, preserves memory, saves time during application initialization, the platform and CPU independence feature. Verification of code safety for IL code provides better security and reliability than natively compiled executable files. The metadata describing the MSIL code in the portable executable eliminates the need for type libraries and intermediate definition language files, as was used in the Component Object Model (COM) technology. Combined with metadata and a common type system, IL forms a means to integrate modules written in different languages into one single application, thus enabling language independence. Although IL is similar to Java bytecode in its usage by compilers, it differs from the latter in that it is designed for platform independence and language independence. It also differs in that it is compiled and not interpreted. Two types of instruction sets are included with IL. Base instructions similar to native CPU instructions and object model instructions used by high-level language. IL includes all instructions necessary for loading, storing, initializing, and calling methods on objects. It also includes arithmetic and logical operations, control flow, direct memory access, exception handling, and other operations. Unlike the common object file format used for executable content in the traditional Microsoft Portable Executable, the portable executable generated after the compilation of managed code contains both IL instructions and metadata. Intermediate language is associated with two IL code tools, which are the MSIL assembler, ilasm.exe, and the MSIL disassemble, ildasm.exe. The former generates a portable executable file from IL code and permits viewing the IL code in human-readable format, while the latter converts a portable executable file back to a text file for viewing and modification. Both are automatically installed as part of Visual Studio. Just-in-time compilation. The JIT compiler is a part of the Common Language Runtime (CLR). This CLR manages the execution of all .NET applications. In addition to JIT compilation at runtime, the CLR is also responsible for garbage collection, type safety, and for exception handling. JIT is a modern software programming language like C# and VB.NET, and it utilizes a human-friendly syntax that is not directly understandable by computers. Software commands in this human-friendly syntax are referred to as source code. Before a computer can execute the source code, special programs called compilers must rewrite it into machine instructions, also known as object code. This process, commonly referred to simply as compilation, can be done explicitly or implicitly. Explicit compilation converts the upper-level languages into object code prior to program execution. Ahead of time, AOT compilers are designed to ensure that the CPU can understand every line in the code before any interaction takes place. Implicit compilation is a two-step process. The first step is converting the source code to intermediate language, IL, by a language-specific compiler. The second step is converting the IL to machine instructions. The main difference with the explicit compilers is that only executed fragments of IL code are compiled into machine instructions at runtime. The .NET framework calls this compiler the JIT, Just-in-Time Compiler. There are three types of JIT compilers available in the latest .NET Framework version. Normal JIT compiler. It compiles methods in runtime as needed. Pre-JIT compiler. It compiles the entire assembly before it has been used. Usually the compilation happens during application deployment. You can pre-compile an assembly using nggen.exe tool, native image generator. EconoJIT. This was a runtime compiler which did not do any optimization and removed methods machine code when it is not required in order to improve compilation time. The compiler is obsolete since .NET 2.0 and you cannot enable it anymore. Garbage collection. The .NET framework manages memory for managed code. All allocations of objects and buffers are made from a managed heap. Unused objects and buffers are cleaned up automatically through garbage collection. Some of the worst bugs in software development are not possible with managed code. Leaked memory or objects, references to freed or non-existent objects, reading of uninitialized variables, pointerless environment. Garbage collector working phase, marking phase, relocating phase, compacting phase. In the marking phase, garbage collector finds and creates a list of all live objects. In relocation phase, garbage collector updates the references to the objects that will be compacted. In the compacting phase, garbage collector reclaims the memory occupied by the dead objects and compacts the surviving objects. The compacting phase moves the surviving object towards the older end of the memory segment. Application installation and assemblies. Hardware requirements. In order to install .NET Framework SDK, following hardware is required. Computer processor, Intel Pentium class, 133 MHz or higher. Minimum RAM requirements, 128 MB, 256 MB or higher recommended. Hard disk space required to install, 600 MB. Hard disk space required, 370 MB. Display, video 800 by 600, 256 colors. Input device, Microsoft mouse or compatible pointing device. Software requirements, Microsoft Internet Explorer 5.01 or later is required. Microsoft Data Access Components 2.6 is also required. Microsoft Data Access Components 2.7 is recommended. Operating System. Microsoft Windows 2000 with the latest Windows Service Pack and critical updates available from the Microsoft Security web page. Assemblies, DLL or EXE file. Smallest deployable unit in the CLR. Have unique version number. No version conflicts, known as DLL hell. Contains IL code to be executed. An assembly is a set of boundaries like a security boundary, the unit to which permissions are requested and granted. A type boundary, the scope of an assembly, uniquely qualifies the types contained within. A reference scope boundary specifies the types that are exposed outside the assembly. A version boundary, all types in an assembly are versioned together as a unit. Avoid multiple version problems for DLLs. An assembly contains a manifest, which is a catalog of component metadata containing assembly name, version, major, minor, revision, build. Assembly file list, all files contained in the assembly. Type references, mapping the managed types included in the assembly with the files that contain them. Scope, private or shared. Preferenced assemblies. Web services. Web services are components on a web server that a client application can call by making HTTP requests across the web. ASP.NET enables you to create custom web services or to use built-in application services and to call these services from any client application. Web services uses a standardized XML messaging system, .xml, used to encode all communications to a web service. In a simple sense, web services are means for interacting with objects over the Internet. The web service consumers are able to invoke method calls on remote objects by using SOAP and HTTP over the web. Web service is language independent, and web services communicate by using standard web protocols and data formats such as HTTP, XML, and SOAP. Unified classes. The .NET Unified classes provide the foundation on which you build your applications regardless of language you use. Whether you're simply concatenating a string or building a Windows service or a multiple-tier web-based application, you will be using these unified classes. The unified classes provide a consistent method of accessing the platform's functionality. You no longer need to learn and master different API architectures to write your applications. You won't need to deploy myriad dependencies such as separate data access library, XML parser, and network API because all of this functionality is part of the .NET framework. Conclusion. In this chapter, the user would have learned about the .NET framework and the following in detail. Common language runtime, common type system, common language specification, the base class library, the .NET class library, intermediate language, just-in-time compilation, garbage collection, application installation and assemblies, web services, unified classes.